We use magnets to do all sorts of things, including making electricity. How? Let's find out. Shoshone Falls is one of the prettiest places in Idaho. It's also a power plant, one of two on this part of the Snake River.
In 1935, they built the original powerhouse at Twin Falls, and they dammed off one of the falls and used the other one, of course, for scenic flows, and began producing power for the Magic Valley. We upgraded to another powerhouse and another unit in 1995 and produced a second unit. So between the two plants, we produce roughly about 53 megawatts, which can power about 40,000 homes for a year.
Ryan Merrick is the operation area leader for the East Region for Idaho Power. He oversees operations at the Twin Falls Power Plant.
So hydroelectric power plants like this one capture falling water and convert that energy from falling water to make electricity. We have a kind of a long tube that comes from the top of our dam down into our power plant, and that allows that falling water to come down and hit what we call a turbine or turbine runner. And as that spins, it's connected via the shaft to the generator.
Merrick checks the generator to make sure it's spinning properly. The magnets used to make electricity are each a few feet in length and are attached in a circle around the shaft of the generator.
So one of the questions I get asked all the time is how many magnets are on a generator? And generators come in all different sizes. Some are big and some are small. So one of the units that we have here has 30 magnets on it. The other unit has 36. Those electromagnets, we call them pole pieces, have a north and south pole. And as those spin around a conductor, in this case a copper coil, electricity flows into that stationary coil, and it flows out from the coil out to our power lines and into our neighborhoods.
It seems like a simple process, but there's a lot more to it.
I have a healthy respect for electricity because if you don't respect it and use it correctly, it can be dangerous and fatal in certain instances. But we have a lot of training, we have a lot of safety equipment that we use that protects us from those live circuits.
Merrick started as a groundskeeper and then got involved in an apprenticeship program with Idaho Power. He worked his way up and is now in charge of this operation. He oversees the plant from its control room.
It's challenging, but at the same time, we know that we're providing an essential service to our friends, our family, and our neighbors.
Creating power from falling water and turning gears is all a part of Merrick's job, and magnets are essential to the process.
If we didn't have magnets to turn around a stationary metal coil, in this case copper, we wouldn't get electron flow, and that wouldn't produce electricity at all. So it really is important to have magnets on our generators.
Knowing how to harness that basic force of the universe and using it to create electricity is why Merrick loves his job.
And that really makes you feel good at night when you go home knowing that you're helping everybody out.
If you want to learn more, head to the Science Trek website or check our related videos. And if you like Science Trek, be sure to click the subscribe button to catch our newest videos.